Okay, we're going to try to estimate the derivative using the TI-84. And I've typed in here the equation for the bungee jumper that we had in our book. And so the bungee jumper, so if I look at the window for this, the x should go from 0 to 20 seconds. And the bungee jumper jumped from height 200, but it's never went below 0. So I'm going to go a height of 0 to 200 feet. So now if I graph this, I should get a picture of that bungee jumper jumping. Okay? And I made a video using Desmos, and I want to do it on the calculator, and we figured out the slope at 2. So I want to figure out the slope at 2. And we're going to do our definition of a limit, or of a derivative, which is a limit of b minus f of b minus f of a over b minus a. Well, here's my function, y1, so that's my f, y1. Now, some of you don't know this, but you can use that as a function notation. And I'm going to go ahead and make this a fraction. Some of you don't have that. You can do it otherwise, but I'll do this one in this way, fraction, and then I'll do the next one, the other definition, in just a fraction one. Type it in. So it's f of b, so it's y1 of b. So y1 is found under vars. So I got to push vars, and then it gives me this screen, and I want the y variables, function, and there's y1. So I select it. y1 of b, but the calculator doesn't, I mean, I could use b. Let's see, maybe I should do that. B is the point that we move. We want b to get closer to a. So I'm going to put x there instead of b. X of y of b minus y1, so I got to go vars y variables function y1, so this same equation, a, the point I'm interested in, and I can put in the letter a, but I'm just going to type in the number. I want to get it at 2. So I'm just going to type 2 over b, which we're calling x, minus a, which is 2. So I'm trying to find the slope of this equation at 2. Now, I have to take the limit of this as x gets closer and closer to 2. So to do that, I'm going to go to my table set, which is right there, and make sure that I'm on ask for the independent variable. And then I'm going to go to table, second graph, table, and then I can, let's get rid of all these. And then I want to get close to 2. Well, 2.1 is close to 2. So I made x get close to 2, and it said the slope is about minus 50.18. But I can get closer to 2, 2.01. I can even get closer, 2.00001. And it's this here is telling me it's putting this into the original function. So the bungee jumper is at about 104 feet, but it's negative, so it's falling at 51 feet per second. That's kind of hard to see in this screen. There you go. That's a little bit better. The reflection of the lights here is not great. Okay. Now let's get closer, not from above 2, but below 2. 1.9, 1.99, getting closer to 2, 1.999, and you see I'm getting that 51.1 as I get the B closer to A. What that means graphically is I got 1 point right at 2, and using B being a little bit above or below, I'm picking points really close to 2 to find the slope. Okay? All right. Now I can also do the other definition, which is, and I'll, instead of using that fraction thing, some of you have calculators that don't. So I have to put my numerator in parentheses, and I want to do y1. Again, that was variable, y variables, functions of a plus h. And I'm looking at 2, so I'm going to put 2 plus h, and h is something I'm going to change, so I'm going to make that be an x in this calculator. So I'm figuring out the point at 2 plus h minus y1 of 2, parentheses, 2 parentheses, close the numerator, divided by h, which I've called x. So now I want x to get closer and closer to 0. And so I will go to my table, and now I want to get x to be really close to 0, because that's the h going close to 0. If I do 0.1, it's pretty close. 0.01, that's closer. 0.00001, and I get really close, and I'm getting that same 51.1. And I can get close from the other side. Negative 0.1, negative 0.01, negative 0.0001, and I'm getting that negative 51. Now what's nice about this second equation is, what if I wanted to know at 5? I can just change the 2 to a 5 and the 2 to a 5, and second enter, and this gives me the answer at 5, which is about 21. These are already correct. I don't want to know at that place when there. This tells me it right away, because it's still using the idea that we want the x to go to 0. So I don't have to change anything because it's going to 0. Up here, to do it on the other one, I would have to say, I'd put in the 5 there, put the 5 there, but then I'd have to go back to my table and make x get close to 5. So when I'm using the h one, it's always to 0, and so it makes it a little nicer to do it.